For decades, the moon lay forgotten beneath the silence of space. After the final sample return mission by the Soviet Union in 1976, humanity's presence on the lunar surface faded into memory. The golden age of moon landings was over, and with it, the dreams of a permanent outpost seemed to vanish. The space race cooled, attention drifted to low Earth orbit, and the lunar dust settled once more. But deep beneath the surface of that silver globe, something remained. Something untapped, unanswered, and deeply alluring. Then, almost as if awakened from a long slumber, the moon returned to center stage. SpaceX rockets blazed new trails into the sky. NASA launched the Artemis program with a bold promise to send astronauts back. And quietly, deliberately, China stepped forward with its own lunar agenda. Whispers of discoveries on the moon's far side began to spread. Nations that once saw space as a Cold War frontier were now racing toward a very different goal. Not just to visit the moon, but to stay. What, after all these years, has brought us back? While the world's gaze had turned elsewhere, a quiet determination began to take shape in the East. In the early years of the 21st century, China, once absent from the original space race, set its eyes on the moon. The China National Space Administration, known as CNSA, was established in the late 1990s, and by the early 2000s, it was laying out a bold, methodical roadmap to explore Earth's nearest celestial neighbor. This plan was not a sprint, but a deliberate marathon, aiming not just for prestige, but for permanence. China's approach was different from the Apollo-era dramatics. There were no urgent deadlines or media spectacles. Instead, it followed a quiet, step-by-step strategy, steadily advancing through technical milestones. The program was named after Chang'e, the mythical moon goddess of Chinese legend, symbolizing elegance and patience. It would be a series of missions, each building upon the last, gathering data, testing systems, and learning how to operate in the harsh lunar environment. Science was the public face. Strategy was the spine beneath it. In the year 2007, China launched its first lunar orbiter, Chang'e-1. This mission marked the nation's maiden voyage beyond Earth's gravity well. From orbit, Chang'e-1 began mapping the entire surface of the moon in 3 dimensions. It created detailed topographic maps, analyzed the lunar soil, and studied mineral composition. Among its early findings was something of particular interest: spectral signatures of helium-3 in the lunar regolith. This was no ordinary discovery. It hinted at potential, energy potential on a planetary scale. The helium-3 deposits were not just a scientific curiosity. On Earth, helium-3 is exceedingly rare. But the moon, lacking a magnetic field or thick atmosphere, has been collecting this isotope for billions of years, thanks to the solar wind. In theory, helium-3 could be used in nuclear fusion reactions, offering a clean, virtually limitless energy source without radioactive waste. For a country looking to secure its energy future, this revelation was not only intriguing, It was strategic. The moon, once a symbol of mystery, now whispered of utility. Three years later, in the year 2010, China launched Chang'e-2, a more advanced orbiter with high-resolution cameras. Its primary mission was to scout landing sites for the upcoming lander. To accomplish this, it flew just 15 kilometers above the surface, photographing terrain in stunning detail. Chang'e-2 verified the safety and flatness of potential landing zones, and it also served as a technology testbed for future deep space missions. This was not just preparation, it was rehearsal. What made these missions particularly significant was the way they blended scientific objectives with long-term infrastructure planning. China was not sending spacecraft merely to take pictures or collect data. It was laying the groundwork for a sustained presence, constructing the lunar equivalent of blueprints. At the same time, its leadership made no secret that space exploration was about more than curiosity. It was about sovereignty, security, and survival. In public, the missions were described as peaceful and cooperative. Behind the scenes, they served multiple purposes. Observers in the West began to take notice. Although China's early missions did not make international headlines, analysts studying orbital telemetry and mission goals recognized the scale of its ambition. The lunar program was being managed with technical precision and significant military oversight. The People's Liberation Army played a central role in CNSA's operations, particularly in launch logistics and communications. This dual structure, civilian and military, echoed the Cold War logic that once drove the United States and the Soviet Union into space. But for all its geopolitical weight, the Chang'e program also reflected a deep scientific curiosity. Each mission brought back invaluable data about lunar geology, terrain morphology, and space weathering. The moon was not simply a destination, it was becoming a platform for innovation, a laboratory for future off-world living. And slowly, mission by mission, China's quiet journey to the moon was gathering momentum. The world, at first skeptical or inattentive, would soon be forced to recognize that a new era had begun, and China intended to lead it. In the closing days of the year 2013, something extraordinary happened on the surface of the moon. For the first time in nearly 4 decades, a spacecraft made a controlled descent and softly landed on the lunar plains. The mission was Chang'e-3, and it marked China's transition from an ambitious newcomer to an undeniable lunar power. The world watched with cautious curiosity, as this was the first soft landing on the moon since the Soviet Union's lunar missions in the 1970s. Chang'e-3 touched down in Mare Imbrium, also known as the Sea of Rains, a dark, basaltic plain on the moon's Earth-facing side. Its descent was guided by an autonomous landing system that used optical cameras, radar altimeters, and onboard hazard avoidance algorithms. This was no mere test flight. It was a major technological leap. Unlike orbiters that simply circle from above, a soft landing required precise maneuvering, fuel control, and terrain analysis, all while descending through the moon's silent vacuum. Moments after the landing, a ramp extended, and from the belly of the lander rolled out a 6-wheeled robotic explorer named U2, meaning Jade Rabbit in Chinese. This rover was named after the companion of the moon goddess Chang'e in Chinese mythology. Small but nimble, U2-1 carried a suite of instruments designed to study the composition of the soil, the layering of the subsurface, and the lunar environment. But it was more than a scientific payload. It was a symbol of rebirth, a silent ambassador wandering a realm long untouched. U2-1 was equipped with a ground-penetrating radar, panoramic cameras, and an infrared spectrometer. These tools allowed it to peer beneath the moon's surface, detecting rock layers and subsurface structures to a depth of several meters. But perhaps most notable was what sat atop the lander itself. For the first time in human history, a telescope had been placed on the lunar surface. This was an ultraviolet astronomical telescope designed to observe the cosmos without the interference of Earth's atmosphere. The idea behind the telescope was bold. Earth's atmosphere blocks much of the ultraviolet light emitted by distant stars and galaxies, making such observations difficult from ground-based observatories. But on the moon, where the sky is always black and the air non-existent, the view is pristine. From Mare Imbrium, the telescope captured ultraviolet images of distant celestial bodies, offering a glimpse of the cosmos from a platform untouched by the atmospheric noise of Earth. Although U2's mission was meant to last 3 months, the harsh lunar night took its toll. Temperatures plunged below -100 degrees Celsius, and the rover experienced mechanical difficulties. Yet, even after its mobility failed, U2 continued to send scientific data from its stationary position for many months. Despite its silence, the mission had already achieved its true goal. China had demonstrated the ability to land, deploy, and conduct science on the moon, an achievement matched only by 2 other nations in history. The success of Chang'e 3 was more than a technical milestone. It was a moment of national pride, a statement to the world that China's long-term presence on the moon was no longer hypothetical. It had begun. The lander and rover remained on the lunar surface, silent but enduring, like statues on an ancient battlefield. And in their stillness, they told a story, not only of machines and minerals, but of ambition, revival, and the quiet determination of a nation reaching for the stars once more. For centuries, the far side of the moon remained a mystery. Always turned away from Earth, it was forever hidden from view, untouched by the telescopes of astronomers and the dreams of engineers. No human eyes had ever seen its surface up close, and no spacecraft had ever touched it. It was a place of legends and silence, a lunar frontier wrapped in shadows. But on a cold morning in January, the silence was broken. A Chinese lander descended into the unknown, rewriting the history of space exploration. The mission was Chang'e 4, originally built as a backup for the earlier Chang'e 3. But instead of duplicating past achievements, China reimagined its purpose. It would not land on the familiar near side of the moon. It would do what no nation had ever done before: attempt a soft landing on the far side. The challenges were immense. The far side is shielded from Earth by the moon's body itself. That meant no direct radio contact, no real-time commands, no way to guide a descent without a bridge across the void. To solve this, China launched a brilliant solution. In mid-2018, they deployed a relay satellite called Kueqiao, or Magpie Bridge, named after the bird from ancient folklore that connects separated lovers across the stars. Kueqiao was placed at a gravitationally stable point beyond the moon, known as Earth-Moon Lagrange Point 2. From there, it maintained constant line of sight to both the far side of the moon and Earth, forming a vital communication link between mission control and the lunar surface. With Kueqiao in position, Chang'e 4 began its descent. On January 3, 2019, the spacecraft touched down in the von Karman crater, deep within the South Pole Aitken Basin, one of the largest and oldest impact structures in the solar system. The landing site was chosen not only for its geological significance, but also for its radio silence, making it an ideal location for delicate scientific experiments. As the lander settled into the ancient dust, a new era began. Quietly, without fanfare, but with historic weight. From the lander emerged Yutu-2, or Jade Rabbit 2, a small rover equipped with ground-penetrating radar, panoramic cameras, and spectrometers. 12 hours after landing, it rolled onto the surface, becoming the first human machine to explore the far side of the moon. The rover surveyed a landscape no one had seen up close, a pitted, rugged plain beneath a pitch-black sky. Unlike the familiar near side, the far side lacks vast lava seas. Its crust is thicker, more ancient, and scarred by countless eons of meteorite bombardment. Scientists had long wondered why the two faces of the moon looked so different. Was it a matter of internal heat or an asymmetrical bombardment? Could the far side hold clues to the moon's earliest moments? With each image, each radar pulse, Yutu-2 brought us closer to answers. It detected layers beneath the surface, uncovering records of ancient impacts and volcanic activity. It examined rocks never weathered by Earth's atmosphere. It transformed the far side from a silent mystery into a living laboratory. But the mission was more than a triumph of engineering. It was a geopolitical message. China had done what others had only imagined. The landing site was selected with care, not just for its science, but for its symbolism. The South Pole Aitken Basin, with its deep craters and long shadows, might one day host the first human base on the moon's far side. And by planting its flag in that terrain first, China had claimed not territory, but precedence. It had stepped ahead in the quiet but growing lunar competition. From orbit to surface, from myth to machinery, Chang'e 4 was a turning point. It showed that exploration was not finished, that the moon still had secrets to share. Through Kueqiao's steady link, the world watched as the far side came into focus, not just as a scientific goal, but as a stage for future dreams. And as U-22 rolled forward, leaving gentle tracks in the gray dust, it carried more than instruments. It carried the weight of a nation's vision and the spark of a revolution in how humanity sees the moon. In the dusty silence of the moon's surface, hidden beneath layers of ancient regolith, lies a substance that could reshape humanity's energy future. It is called helium-3, a rare isotope that barely exists on Earth but is thought to be abundant on the moon. For decades, it was a theoretical prize, an exotic possibility whispered among physicists and visionaries. But thanks to China's lunar missions, that whisper has become a conversation. The Chang'e program did more than explore. It began to map a resource that might one day power our world. Helium-3 is not produced naturally on Earth in significant quantities. It arrives here primarily through the solar wind, a stream of charged particles from the sun. But Earth's thick atmosphere and magnetic field prevent most of it from reaching the surface. The moon, however, has no such protection. For billions of years, it has silently absorbed these particles. Over time, the solar wind has embedded helium-3 atoms into the upper layers of lunar soil. This silent accumulation has transformed the moon into a vault of nuclear potential. The idea is as revolutionary as it is elegant. In theory, helium-3 can be used in nuclear fusion, the same process that powers the stars. Unlike conventional fusion reactions, which produce dangerous neutron radiation, helium-3 fusion is clean. It releases tremendous energy with little or no radioactive waste. A few ounces of helium-3 could provide the same energy output as thousands of tons of coal, without the pollution. This makes it not only valuable, but possibly the most efficient fuel source ever conceived. Chinese scientists knew this early on. From their very first missions, the Chang'e orbiters and landers carried instruments capable of detecting and mapping helium-3 concentrations across the lunar surface. But the breakthrough came in 2020, when the Chang'e 5 mission returned to Earth with a payload of lunar soil from the Oceanus Procellarum region. Among the many grains of gray dust and crystal fragments, researchers found something extraordinary, a previously unknown mineral, later named Changesite Y. This was not just a scientific curiosity. Changesite Y, a transparent columnar crystal, was confirmed to contain traces of helium-3. It became the first lunar mineral officially discovered and named by China, and only the 6th new mineral ever found in lunar samples. Its identification not only confirmed earlier spectral readings, but also served as physical evidence of the moon's potential as an energy reservoir. For China, it was more than validation. It was proof that their systematic exploration was beginning to yield strategic rewards. The implications are enormous. Estimates suggest that over 1 million tons of helium-3 may be present in the moon's upper soil layers. That could be enough to power Earth for thousands of years. Of course, extracting it will require advanced mining technologies, as well as a way to transport and process the isotope safely. But for the first time, the pieces of that future are beginning to fall into place. And with the discovery of Changesite Y, the idea of a lunar energy economy is no longer the stuff of science fiction. It is becoming science fact. In the middle of a routine lunar exploration in mid-2019, the Chinese rover Yutu-2 came to a sudden stop. It had encountered something strange, a substance unlike anything seen before on the moon. Nestled within a small crater was a patch of glossy material, dark and smooth, with a texture that seemed to glisten in the rover's cameras. This was not just another rock. It was something entirely unexpected, and for a brief moment, it cast a shadow of wonder and speculation over the entire mission. The team operating Yutu-2 called it a gel-like substance, a curious description that immediately ignited interest beyond the scientific community. The moon, after all, is an airless, bone-dry world with no liquid water and temperatures that swing wildly. How could anything appear sticky or molten? Was it the remnant of volcanic activity, the product of a meteorite impact, or something even stranger? With no immediate explanation, the mystery deepened, and the world began to ask, what exactly did China find? Adding to the enigma, Chinese space authorities withheld images of the substance for several weeks. That silence proved louder than any announcement. Without visuals or clarification, speculation erupted online. Was this a biological sample, a sign of alien activity, or evidence of something hidden beneath the surface? On internet forums and tabloid headlines, the mystery gel became a symbol of everything unknown about the moon, and perhaps a hint of secrets not yet shared with the world. Eventually, the images were released, and scientists got their chance to examine the material. It was not slime, nor was it organic. Spectral analysis revealed that the shiny patch was likely impact melt breccia, soil and rock fused together under the intense heat of a meteorite strike. This was lunar glass, rich in minerals such as olivine and pyroxene, similar to samples once brought back by Apollo astronauts. Though not extraterrestrial life, it was still a rare and valuable clue to the moon's violent geological history. In the end, the mystery gel turned out to be glassy rock, but the frenzy it caused reflected something deeper. It revealed how even today, with all our scientific tools and data, the unknown still captures the human imagination. For a brief moment, a patch of melted regolith inspired the same curiosity that once drew ancient astronomers to map the night sky. The mystery gel was no revolution in science, but it was a reminder. We are still explorers, and the moon still holds surprises for us. But the lunar riddles were not over. In late 2021, Yutu-2 once again drew attention, this time not for what lay beneath its wheels, but for what stood far in the distance. On the horizon, the rover's cameras captured a strange silhouette, a cube-shaped object standing upright on the gray plain. The image quickly spread across the globe. It looked almost artificial, like a block placed deliberately. Internet users gave it a name, the Mystery Hut. Once again, theories abounded. Was it a monument? A shelter? Could it be proof of alien architecture or a lost remnant of some unknown past? The scene recalled iconic imagery from science fiction, the monolith in Stanley Kubrick's film, or the ancient ruins of speculative worlds. For weeks, as Yutu-2 slowly crept toward the object, media outlets and online communities kept watch. Jokes and wild guesses filled the digital space, blurring the line between science and storytelling. As the rover approached over the course of several lunar days, the truth emerged. The Mystery Hut was simply a rock, an irregularly shaped boulder perched near the rim of a crater. Its cube-like appearance was an illusion of distance, light, and shadow. Up close, it bore no sharp edges, no mystery. But in a poetic twist, the rock resembled a crouching rabbit, perfectly fitting, as Yutu means jade rabbit in Chinese. The rover, it seemed, had found its own mythological reflection. These episodes, the glistening gel and the illusory hut, did more than entertain. They revealed how easily curiosity blooms in the presence of mystery, especially in places as remote and ancient as the moon. While science offered rational answers, the public imagination ventured into fantasy, reminding us that exploration is not just about data, it is also about dreams. In a world often defined by certainty, the moon remains one of the few places where wonder is still allowed to grow in silence. The discovery of the mysterious gel and the strange lunar silhouette did more than capture scientific interest. They exposed a deeper psychological truth. When images were released slowly, when details were sparse, imaginations filled the silence. In the absence of explanation, mystery became a canvas. And in that space, the media took hold. Headlines speculated, forums erupted, and millions followed the story, not just as observers of science, but as participants in something that felt larger, more mythic, more unknown. What these moments revealed was not merely curiosity, it was yearning, a desire for something extraordinary to be hidden in the dust of the moon. Even in an age dominated by data and logic, people still long to believe in the improbable. Not because they distrust science, but because the unknown holds a timeless appeal. In that gleaming patch of soil or the distant shape on the horizon, many saw more than geology. They saw possibility, the chance that the universe was holding its breath, waiting to surprise us. As speculation surged, so did conspiracy. In some corners of the internet, whispers turned into wild theories. Some claimed that China had found ruins, ancient structures buried beneath the regolith. Others insisted that the delay in releasing photos was proof of a cover-up, a secret base, alien technology, or evidence of a civilization erased from memory. None of these claims had scientific support, yet they spread quickly, fueled by viral media and a cultural climate shaped by distrust, wonder, and digital storytelling. Scientists were quick to respond. Spectral data showed that the gel was impact glass. The cube was a rock, nothing more. But facts did not quiet fascination, because while science explained the physical, it could not fully erase the symbolic. The moon's far side, long shrouded in mystery, had become a mirror, reflecting both the truths we discover and the stories we project. Its silence does not just invite measurement, it invites myth. And in doing so, it reminds us that exploration is never only about what we find, it is also about what we hope to find. In the end, these episodes tell us something profound. The far side of the moon is not merely terrain, it is metaphor. A reminder that in the shadowed places of the cosmos, we place our fears, our hopes, our symbols. When science and story collide, it is not always conflict, it is connection. Because behind every rover, every mission, every photograph from the void, there is something deeply human at play, a longing to understand, and a willingness to dream beyond what is already known. In January of the year 2019, while much of the world focused on lunar geology and engineering feats, a quieter revolution unfolded inside a small metal container aboard the Chang'e 4 lander. It was no larger than a paint bucket, sealed tight and nestled safely within the probe. Inside it were seeds, soil, air, and a vision. An experiment not of machinery, but of life. For the first time in human history, Earth-born biology was about to awaken on another world. The experiment was simple in design, but monumental in ambition. Chinese scientists had created a self-contained mini biosphere, an artificial ecosystem with cotton seeds, potato seeds, yeast, and fruit fly eggs. The goal was to observe whether life could begin, however briefly, under the harsh conditions of the moon. No water from Earth, no open contact with the lunar surface, just a sealed bubble of life, placed gently on a world that had never known anything living. And then, it happened. Within days of landing, one of the cotton seeds sprouted. A pale green shoot curled upward from the soil, illuminated by a soft artificial light. It was fragile, almost translucent, but unmistakably alive. That single sprout became the first living organism ever to grow on the moon. It was a moment that bridged two worlds, the living cradle of Earth and the lifeless, ancient silence of the lunar surface. a tiny green leaf against an endless gray wasteland. Photographs of the sprout were released soon after, sparking astonishment and excitement across the globe. Scientists, students, and dreamers alike saw in that delicate stem a vision of the future. Could we one day grow crops on the moon? Could this be the first step toward building greenhouses, sustaining astronauts, or even nurturing colonies far from home? In that fragile life form, many saw more than a plant. They saw a beginning, a whisper that Earth life could stretch its roots into the cosmos. But the experiment was never meant to last. After about 2 weeks, the lunar night fell. Temperatures plunged to below -170 degrees Celsius, and without sunlight, the tiny ecosystem's heaters shut down. The cotton sprout withered and died as expected. No other seeds hatched. The fruit fly eggs and yeast cells remained dormant. Yet, failure was never the point. Even in death, the experiment had already proven what needed to be known. Life could begin on the moon, even if only for a moment. What made this achievement so profound was not the sprout itself, but the context. The moon has no air, no liquid water, no organic soil. It is bathed in cosmic radiation and experiences extreme temperature shifts. And yet, within a few days of arrival, life had emerged. This suggested that controlled environments, greenhouses, sealed habitats, biodomes, might one day allow humans not just to visit the moon, but to live and grow food there. The experiment became a proof of concept for future survival beyond Earth. Long after the sprout faded, its meaning endured. That lone leaf was more than a biological event. It was a symbol of human ingenuity, of resilience, and of hope. In the midst of lunar dust, where no river flows and no breeze stirs, something had grown. It was humble, small, and short-lived. But it told a powerful story, that life is not bound to Earth. That with care, imagination, and perseverance, we may one day make the barren bloom. On a lifeless world, we planted a seed, and it answered. When Chang'e 4 touched down on the far side of the moon, it did not just land on lunar soil. It landed squarely on the world's radar. For decades, the moon had been largely untouched, seen more as a historic milestone than an active frontier. But China's successful landing and the steady stream of data that followed sparked immediate attention. Around the world, scientists and space agencies took notice, not because they had been unaware, but because the symbolic silence of the far side had just been broken. In the United States, NASA publicly acknowledged China's accomplishment. The administrator at the time, Jim Bridenstine, praised the mission and welcomed its contribution to lunar science. American researchers, though barred by law from official collaboration with their Chinese counterparts, openly expressed admiration for the technological feat. European scientists also joined the applause, especially given that some of their instruments had been included on the Chang'e missions. The global scientific community, though divided by politics, was united in its curiosity. But beneath the scientific congratulations, there was something more cautious stirring: concern. Analysts in Washington, Brussels, and Tokyo began to ask deeper questions. Was this only a mission of exploration, or was it something more? The involvement of the Chinese military in space operations was well known. The China National Space Administration, while civilian in name, works closely with defense authorities. In Western capitals, some quietly wondered whether the moon had just become a new arena for strategic positioning. Chinese officials emphasized the peaceful and scientific nature of their lunar program. They highlighted international contributions and shared limited mission data. Yet some observers remained skeptical. The tight control over information, the delayed release of images, and the highly curated communication style raised eyebrows. Was the program as transparent as it claimed? Or was it part of a broader, long-term strategy to establish technological and territorial advantages in space, shielded from public scrutiny? The concern was not entirely unfounded. The moon's far side is radio silent, making it an ideal location for sensitive scientific experiments, but also, potentially, for military installations. While there is no evidence that Chang'e 4 carried any non-scientific payloads, the precedent was unsettling for some. If one nation can access and operate on the far side in isolation, what prevents others from doing so with less peaceful intentions? The lunar surface, once thought immune to Earth's rivalries, now appeared slightly more vulnerable. In the aftermath of Chang'e 4, many began to speak openly of a new space race, not the frantic Cold War dash to plant a flag, but a slower, more strategic contest for access, presence, and influence. The moon had returned to global relevance, not only as a platform for science, but as a testing ground for soft power. China had taken the initiative, and others began to follow. New missions were announced, budgets were revised. The moon was no longer symbolic, it was geopolitical real estate. As of now, there is no open conflict in space. There are treaties, accords, and cautious diplomacy. But the Chang'e missions have changed the conversation. Lunar exploration is no longer simply about discovery. It is about positioning, prestige, and potential control over future resources. The question that lingers in international circles is not whether we will return to the moon. That is already happening. The real question is who will lead, who will follow, and whose vision will shape the future of the lunar frontier. For centuries, the moon was seen as cold and barren, a celestial wasteland of dust and silence. But hidden within that dust lies a treasure, a potential energy source unlike any found on Earth. It is called helium-3, a rare isotope delivered over billions of years by the solar wind. Trapped in the upper layers of the moon's soil, helium-3 offers something almost magical: the promise of clean nuclear fusion. And unlike conventional nuclear fuel, it could power the world without the poisonous legacy of radioactive waste. In theory, helium-3 can be used in fusion reactions that release enormous energy but produce very little radiation. A few ounces of this substance could provide as much energy as thousands of tons of coal, with no greenhouse gases and no long-lived nuclear byproducts. Scientists have dreamed of it for decades. Now, with lunar samples in hand and analysis confirming its presence, that dream is edging closer to reality. The moon, it seems, might not just be a stepping stone, it could be a battery. China's lunar missions have consistently mapped the distribution of helium-3. Orbiters scanned the surface from above, while landers and rovers sampled the regolith directly. Spectrometers detected its signature, and laboratory results from Chang'e 5 confirmed traces of it embedded in newly discovered minerals. These missions are not just explorations, they are surveys, prospecting missions for the nuclear age. The information they gather may one day guide mining equipment and fusion reactors far from Earth. But harvesting helium-3 is no simple task. To collect it in meaningful quantities, entire stretches of lunar soil must be heated to hundreds of degrees Celsius. That requires infrastructure, power, automation, and long-term planning. The process is energy-intensive and slow, and the isotope itself must be stored and transported with extreme care. No nation today has the full capability to do this, yet the fact that governments and private companies are even considering it shows how serious the pursuit has become. Yet, helium-3 is not the only resource stirring interest. At the lunar poles, in craters cast in eternal shadow, something even more essential has been found: water ice. Hidden from sunlight for billions of years, these frozen deposits may be the key to future life beyond Earth. Water is more than a drink. It can be split into hydrogen and oxygen, used for breathing, and burned as rocket fuel. In space, where every supply must be launched from Earth, the ability to extract water locally is revolutionary. Chinese scientists have taken notice. Future Chang'e missions are targeting the South Polar region, where vast, permanently shadowed craters may hold ice in abundance. Soil samples from Chang'e 5, though collected at mid-latitudes, also revealed hydroxyl water, molecules implanted in lunar minerals by the solar wind. Combined with solar energy and in-situ resource utilization technologies, this opens the door to a self-sustaining lunar base, a place where astronauts could live, work, and fuel their return without constant resupply from Earth. In the long run, whoever masters lunar resource extraction will gain more than energy. They will gain influence. Helium-3 could reshape the global energy market. Water ice could support permanent settlements, and both together form the foundation of an off-Earth economy. That is why the race to the moon is not only about science, it is about strategy. The craters and basins once dismissed as lifeless are now seen as vaults of survival. In the moon's cold silence, the future of energy may already be waiting. The Chang'e program did not end with the landing of a rover or the discovery of a new mineral. It was never meant to be a single moment. It was always a path, a sequence, a deliberate roadmap designed to turn presence into permanence. With every mission, China has moved closer to that vision. After the far side landing of Chang'e 4, attention shifted once again to the retrieval of samples, deeper exploration, and the first real steps toward building something that would last on the moon. In late 2020, the Chang'e 5 mission made history once again. For the first time in over 4 decades, lunar samples were returned to Earth. The spacecraft collected over 4 pounds of lunar soil from the near side, specifically from Oceanus Procellarum. The rocks gathered were among the youngest ever found on the moon, estimated to be around 2 billion years old. This successful mission demonstrated China's ability not only to land and analyze, but to bring precious material back across the void. Then came Chang'e 6. Launched in 2024, it set out to retrieve samples from the far side of the moon, a feat no other nation had ever attempted. The probe landed in the South Pole Aitken Basin and drilled into the ancient terrain. When it returned to Earth, it carried not only soil and rock, but also a promise. These samples may contain answers to questions about the moon's deep history, its asymmetrical geology, and the long-standing mystery of why its 2 faces are so different. Now, China sets its sights on the South Pole. Chang'e 7 is expected to launch before the end of the decade. This mission will not just land, it will scout. Using a combination of a lander, a rover, and even a small hopping probe, it will search for water ice and study the polar environment. Permanently shadowed craters in this region may hold vast stores of frozen water. If confirmed, these reserves could be used for life support, fuel production, and the foundation of a long-term lunar presence. The follow-up mission, Chang'e 8, will take things even further. It will test in situ resource utilization technologies, methods that allow astronauts or robots to use local materials rather than relying on supplies from Earth. It may involve 3D printing with lunar soil to create building materials or infrastructure components. This mission could mark the beginning of construction on a permanent lunar outpost. For the first time, China will move from visiting the moon to shaping it. These missions all feed into a larger vision. The International Lunar Research Station, or ILRS China, with potential cooperation from Russia and other nations, aims to establish this base at the lunar South Pole by the early 2030s. The station would serve as a hub for science, exploration, and perhaps even habitation. Unlike the Cold War-era rivalry that first sent humans to the moon, this roadmap speaks of long-term positioning, a place where science meets sovereignty, and where the next great chapter of space exploration may quietly begin. While China steadily advanced its Chang'e program, the United States was preparing a response of its own. Out of NASA's long-term vision emerged a bold new initiative, the Artemis program. Named after the twin sister of Apollo, Artemis aims not simply to return to the moon, but to build a permanent presence there. This is not a replay of the past, it is a reinvention. Supported by a growing alliance of nations and powered by partnerships with private industry, Artemis has become the cornerstone of America's return to deep space. Unlike the space programs of the 20th century, Artemis is not a solo venture. NASA has partnered with companies like SpaceX and Blue Origin, combining government planning with private innovation. The result is a hybrid architecture that uses reusable rockets, lunar landers, and modular systems to reduce cost and increase flexibility. The United States has also formed international partnerships through the Artemis Accords, a diplomatic framework signed by over 24 countries, outlining principles for peaceful exploration and cooperation on the moon. Like China, NASA has set its sights on the lunar South Pole. This region, with its peaks bathed in near-perpetual sunlight and craters cloaked in eternal shadow, offers both power and promise. It may hold significant reserves of water ice, essential for life support and fuel. The South Pole is now viewed as the most valuable real estate on the moon. And that has raised a difficult question. What happens when two rival programs aim for the same piece of ground? The finish line is not a flag. It is location. In recent years, both NASA and the China National Space Administration have outlined plans to land near the same areas. The timelines overlap. The ambitions echo one another. This has raised concerns in Western strategic circles. Could overlapping goals lead to competition or even conflict? Officials in Washington have begun to view lunar presence as a matter of national interest. After decades of space being treated as neutral ground, the moon is being reconsidered, not only as a destination, but as a frontier of influence. This new lunar race is not a dramatic sprint, as in the Cold War era. It is a slow, deliberate contest of infrastructure, alliances, and access. Artemis and Chang'e may never meet face-to-face on the moon, but their trajectories are converging. Two visions, two coalitions, and one silent world between them. The South Pole has become the stage, and the stakes extend far beyond exploration. In this quiet contest, strategy matters as much as science. The moon, once a symbol of unity, is now a map of emerging power. As the 21st century unfolds, the moon has become more than a symbol of exploration. It is now a strategic destination. Two visions are emerging on its surface. On one side stands the Artemis Coalition, led by the United States and supported by a growing list of international partners. On the other, the International Lunar Research Station, spearheaded by China with the support of Russia and others. These two programs are not simply scientific. They represent competing models for how humanity should return to the moon, and for what purpose. But the question of collaboration or confrontation may not be answered by missions alone. It may be shaped by law. The Outer Space Treaty, signed in the year 1967, forbids nations from claiming sovereignty over celestial bodies. Yet it says little about extracting resources. As countries prepare to mine the moon for water, helium-3, and other materials, new legal frameworks will be needed. Will we see a unified code for the stars, or a patchwork of rival rules? The moon may soon test the limits of Earth's diplomacy. In this emerging moon race, there is no gunfire, no borders, no battleships. But make no mistake, it is a race. A race of architecture, timing, access, and ideals. Whether it leads to a new era of global partnership or a slow drift toward division remains unknown. The moon offers enough space for many, but only if nations are willing to coordinate. The choice now is not only where we land, but how we build. In the dust of a distant world, humanity must decide: will we plant flags or foundations? Once veiled in permanent shadow, the far side of the moon has now been touched by human hands. What was once a symbol of the unknown has become a theater of action, a place where science, ambition, and strategy quietly converge. The far side is no longer simply a mystery in the sky. It is a frontier, one that has revealed not only geological wonders, but also the complex interplay between discovery and power. In a few short years, a place that once hid from all human eyes has become a mirror to our most human intentions. The implications of these lunar missions do not stop at the edge of the moon. They echo back toward Earth, toward our energy future, our technological capabilities, and our diplomatic balance. Helium-3 could one day light our cities. Water ice may sustain colonies beyond Earth's reach. But perhaps more significantly, the way we approach the moon reveals the kind of species we are becoming. Are we builders or claimants? Are we guardians of knowledge or competitors for control? In exploring the moon, we are also exploring ourselves. Throughout human history, the moon has been a symbol. It has represented gods, lovers, calendars, and dreams. But now it has become something more tangible, something with stakes. With every rover deployed, every crater mapped, and every mineral analyzed, the moon is being redefined. Not as a distant light, but as a platform. A place where nations test not only machines, but resolve. And with that shift, the symbolism changes. The moon is no longer just a reflection of our hopes. It is now part of our plan. We stand today at a turning point. The next chapters of lunar exploration will not be written by a single nation, nor dictated by a single vision. Instead, they will emerge from the delicate dance between cooperation and rivalry, transparency and ambition. The moon may be vast, but its key locations, those with sunlight, ice, and scientific value, are few. The choices we make now will determine whether the moon becomes a shared sanctuary or a fractured frontier. In its silence, it is waiting for our answer. As we gaze upward, one question remains. Will we share the moon, or once again compete for it? Will we learn from the past, or repeat it among the craters and ridgelines of another world? The moon reflects more than sunlight. It reflects who we are becoming. In this new era, it is not enough to reach the moon. We must decide what we will do when we get there, and perhaps more importantly, who we will be. If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.